Uh, Guys, I'm audible. I think I'm audible. If I'm audible, just make a comment. Yes. Okay. So yeah, first, mm, Merry Christmas. Today, 25th December, 2025. Okay. So okay. So everyone, it's very warm welcome to this live. I'm super excited to see you guys here today. So, guys, guys, raise your hand if you use a Windows laptop or a PC. Yeah, okay. Or like almost everyone, right? Everyone use Windows. Okay. So we use Chrome to browse the internet. We use VLCs to watch movies. Maybe you guys use VS Code to write some program. But have you ever thought that about how this program actually work? Like think of Windows like a massive, highly secure VVIP building. Okay, inside this building there are two main zones. Okay, so the zone 3. Okay, so the zone 3 is the lobby. Okay, so if you see the zone 3, okay, so the zone 3 is the lobby. Like there's everyday people hang out. This is called the user mode. Your web browser, your games, your calculator, they all live here in this lobby. It is a safe, but they don't have much power. Okay, then there is a zone 0. Okay, so there is a zone 0, the kernel mode. Okay, the high security basement. This is where the electricity generator, like the main water pump supplier, okay, and the deepest secrets of this building, and this is called the kernel. Okay, so now here is the problem. Okay, so uh, if your browser want to save a file, it's need a access to the hard drive, which is controlled by the high security basement, the kernel. But the web browser is not allowed to downstairs. Okay, it's too dangerous to let every random program touch the code, the hardware. Okay, so how do they talk to each other? Okay, so the Microsoft built a special bridge, a translator, a set of strict rules. This is called the Windows API, or we usually say it's a Win32 API. Okay, so you can see the bridge. Okay, Win32 API. Yeah, I generate using the Google Gemini. Using AI is the best. Okay, so okay, so if Chrome wants to save a file, it cannot just grab the hard drive. No, it has to go the Win32 API, the bridge, and say, excuse me, Mr. API, here is a file, please save it for me. The API take the file, check if everything is okay, goes down to the basement and get the job done safely. The Win32 API is the massive collection of functions, thousands of commands that allow program to talk to the deep system. It was designed to help developer build amazing things. Okay, so you will see that there is a user. Okay, and there is a Windows kernel, and this is the bridge Win32 API create. Okay, so if anyone want to use this kernel, they just go through this bridge. Okay, this is the main funda. So the thing is, here is the twist in our story. The bridge does not care who is working on it, right? So it does not know the difference between a good guy program or a bad guy program. Imagine a master key that opens every door in the hotel. The manager used to help guests, but if a thief can steal that exact same master key to loot the rooms. So malware developers, the hackers, realized this is a long time ago. They realized, why should I try to break walls of the building when I can just use the official bridge? Today, almost every piece of advanced malware uses the Win32 API. They use the API's official hide the window function to make themselves invisible. Okay, invisible to you. That's what we call the evasion. Okay, then they use the APIs officially, like run the program at the startup. Okay, so it's the function to make sure they come back every time you reboot. That's their persistency. Okay, they use the API to manipulate memory, steal passwords, and control the system. Okay, so that's why the Windows API 32 is the most important part in the malware development. Okay, so now, like, imagine your computer is a massive high security government building. Okay, so the operating system. Okay, so yeah, okay, we just think that your operating system is a government building. Okay, the most powerful person in the building is the CM, chief minister. Okay, and we call the CM the Kernel, the most powerful man. He sits in a super secure bunker called kernel mode. He controls everything, the memory, like the hard disks, the phone lines, the network, and the CCTV, the screen. Okay, so you and your application like the Chrome, Notepad, or even the malware are just a common people, common citizens. You live in the waiting area called user mode. Okay, so you are not allowed to meet a chief minister directly, right? So if you want to open a file which is like ask for a government document, you have to follow a strict protocol. Okay, so the protocol, the execution flow. Okay, let's say your application, the Notepad, want to open a file. Okay, so they use the create file. It cannot just walk into the bunker. Okay, so there is some steps. So if you see the whole example, so we sit in the user mode. Okay, in there is a Notepad, there is a malware, there is a Chrome. Okay, so the first step, the receptionist. Here is the receptionist, kernel32.dll. Okay, so Notepad goes to the front desk. This is the kernel32.dll. Okay, so this is the friendly receptionist who speaks English. Okay, you say, hello sir, you want to open a file? No problem, let me forward your request. Okay, then the step to the assistant, kernel this DLL. Okay, so this receptionist send the form to the assistant. Okay, he checks if you fill out the form correctly, like the validation. Okay, did you write your name? Is the file path correct? Okay, then the step 3, the right hand man. Okay, so the right hand man is the NTDLL. Okay, so the right second, it's not working. So the right hand path is NTDLL. Okay, so it's goes through here. Okay, no, okay, wait, first, yeah, it's check, and then it goes, and then it goes there. Okay, so the assistant forward the request to the most serious guy in this in the building, the ntdll.dll. Okay, and then this guy sit right outside the chief minister door because he's a right hand. Okay, so he does not smile. He converts your polite request into the CM secret language, and he create a file that called nt create file. Okay, I just transfer the create file to empty create file. Okay, then the secret build. This is the secret build. We will use syscall. Okay, we will use the syscall. We use the syscall. Okay, so this is the critical moment. The right hand man write a secret token number like the has 45, okay, on a slip or paper. We call the paper EAX register. Okay, so he just press a special button called syscall or the sys enter. Okay, so next the bunker, the kernel mode. So boom, like the floor open. Okay, we just like the drop the request in the bunker. Okay, so the chief minister, the kernel sees the token has 45, know exactly what to do, like grabs the files and send it back to up. Okay, so we understand the system DLLs. Okay, like think of Windows as a big government office. Yeah, so with different department, each different department handles a specific job. Okay, so like you guys can see the chart. Okay, so each department have their own work, like the inter DLL, the kernel 32 DLL, the user 32 DLL, the GDI, the advanced API, and the WS232 DLL. Every guys have their own job role, and they use the different Windows APIs, like the integrate files, create process, message box. Okay, and the raise open key. Every these things is a Windows API. Okay, the functions. Okay, so you guys just screenshot this chart. Okay, so now the question, how Windows organize all these things. So Microsoft organized thousands of functions into a logical groups, just like a library. Okay, so there is a user interface, like this is everything you see. Like Windows is an event driven system, like all a waiter waiting for you to wave your hand. Okay, you want to click a mouse, Windows put a click message in the mailbox. The application read it and run a function called WNDproc. Okay, so Windows procedure. It's also a Win32 API to decide what to do. Okay, so you click close the event, Windows sends another message, WM close, the app is closed. Okay, then the data access, Windows have many ways to store data, from simple text to file to complex database. Okay, so file system, the standard way to save data, we in Windows use NTFS. Okay, it even has volume shadow copy. Okay, which is like time machine for your file, the backups. Okay, and this is the magic. You guys copy paste many things. Okay, so copy paste memory that lets different apps share data. Okay, and the third, the system service. So these are the things running in the background to that you don't see. Okay, like the managing memory, RAM, the threads, workers. Okay, this includes everything from Wi-Fi to Bluetooth. It uses protocols like TCP, UDP to talk to the world. Okay, so now the question, why does malware love this? Okay, so the malware, or we call the villain, does not want to break the door, right? So we just want to use a receptionist, the kernel 32, to do this dirty work. Okay, so he asks the receptionist politely, please open this file, please start this virus. Okay, and the receptionist does it because we, the hacker, or we are not hackers. Okay, so he okay, so he follows the rules. That's why receptionist does it. Okay, so okay, so we will learn how to trick these departments into doing what we want. Okay, So the insider threat. Okay, so we already know that the Win32 API is the official bridge to talk to the operating system. Malware developers are smart. They don't build their own suspicious tool. Instead, they use the operating system's own tool against it. Okay, it is like a thief using a bank own key to rob the bank. Okay, so we have the three main scenes of malware attack. Okay, so first the process injection. Yep. So imagine a criminal malware want to rob a bank. If you walk in a wearing a mask, the security guard, the antivirus will catch him immediately. Okay. So what does he do? He finds a trusted bank employee. So he finds a trusted bank employee. Okay, a legitimate process like the chrome.exe or the explorer.exe. Okay, and hide inside their pocket. Okay, now to the security guard, it just looks like the honest employee is working. Okay, so the first we do the open process. Okay, so the thief picks a target. Okay, so we picked a target. It's a trusted explorer.exe. Okay, we asked Windows for the permission to touch that process. This is like stealing the employee ID card to get into their office, and for this we use okay, no, so we ID card to get in, like the we enter the room. Okay, so now we need a memory. Okay, so for this we allocate a section. So first, when we enter the room, we use the Windows API key open process. Okay, now we need a room to do work. That's why we use another function, the virtual alloc Okay, so now the thief is inside the employee's office, the memory space. We create a memory. We allocate a memory. Okay, so he needs a desk to work on. Okay, he asks Windows, hey, give me some empty space in this room. So Windows allocate a new empty memory block. You can see that they create a empty space. Okay, now the payload deployment. For this we use the function write process memory. Okay, so the thief take his secret weapon, the malicious code or the shell code, and put it on the new disk. You can see they just put it the malicious or shell code in the disk. Okay, now the bomb is planted and inside the trusted room. Okay, now the execution part. Okay, for this we use another Windows Win32 API, the create remote thread. The bomb is there, but it needs someone to press the button. Okay, so the thief hired a new worker, the thread. Okay, inside that office, and tell him go to the desk and start working. The code run, the antivirus sees explorer.exe doing something, so it thinks, oh, it's just explorer, let pass him. Okay, and the advanced move, the advanced malware use the another Win32 API. It says set thread context. So instead we hiring a new person, new worker, the thief manipulate an existing worker. Okay, he manipulate a existing worker and force them to stop the normal job and run the malicious code instead. This is called the threat hijacking. Okay, now the next part. Okay, now the next part, the persistency. Okay, so malware knows that the user will eventually shut down the or restart your computer. When you restart, the malware die, like get removed from the RAM. To survive, the malware need to make sure Windows automatically invite it back every time the computer turns on. Okay, so there is some method we do for the persistency. Okay, so the first, the registry run key, the attendance register. Okay, so 1 second. Yeah, so you guys see the another story. We just so we just first we do the registry. Okay, so Windows has a special morning attendance list, the registry. Okay, so when the computer wake up, it checks this list to see who needs to start working. Okay, the malware use a function called the, okay, it's there, the function, the reg set voltex. It's another Win32 API. Okay, it's so what is that? It's just write its name on this list. Now every time you log in, Windows politely start the virus for you. Okay, now the VIP stuff, the the Windows service. So service is special program that run in the background before you even log in, just like a Wi-Fi driver. Okay, so advanced malware use create service. They use another API, create service. Okay, to register itself as a system helper. It's run with high privilege, just like a VIP. Okay, so I'm telling that the malware development is an art. Okay, you are the artist. If you think as an artist, then you make your malware more advanced. Okay, so or choose the perfect Win32 APIs. Okay, and next, the alarm clock. Okay, we just schedule a task. Okay, so the malware tell Windows like wake me up every day at 9 a.m. Okay, so even if you delete the file, the alarm clock, the task scheduler will try to run it again. Okay, now the information thief. Okay, so the malware is the running and persistent. Now it want to steal your secrets like the password, the credit card numbers and all. Okay, so for this we using different types of Windows APIs. Okay, so there is some methods we talk, like the basics ones. Okay, so the first we use set Windows hook X. Okay, so what is it? It's like the right app. Okay, so this is a James Bond move. Okay, so malware install a hook on your keyboard. You will see it's the hook. So malware hook install your keyboard. It tells Windows every time the user process a key, send a copy of that later to me first. Okay, so this is called the key logging. You type your Facebook password and the malware get it before Facebook does. Okay, this is the very smart move. Okay, so now the second one, I don't like the second one because it's like it's a dumber method. Okay, so it's an annoying kid. Okay, this is a simpler and very stupid things. The malware constantly asks the keyboard every millisecond, is A pressed, is B pressed, is enter pressed. Okay, so it's you guys just see that every time they just ask is A pressed, is B pressed, is enter pressed. Okay, so it's work, but it's make the computer slow. Okay, and the third one we use the LASIX. Okay, so there is a special security guard in Windows called LASIX. Okay, las okay, LSASS. Okay, so it's a full form of local security authority subsistence service. Okay, whoa, it's very big. Okay, so you just hold the key and the passwords for your login session. Okay, so malware attacked this guard to steal the password directly from his memory. This is how hackers steal the administrator password. Okay, so now the part the so it's like we want our malware invisible. Okay, so in the old days antivirus was like a simple security guard. Okay, he had a list of bad guys, we call it the signatures, malware signature. If your face was on the list you got caught. Okay, but today we have EDR, endpoint detection and responses, is a bitch. So EDR is like a high-tech smart police. They don't just look at the face, they watch the behavior. They put CCTV cameras, like they using some hooks everywhere inside the windows. So the modern malware had to involve. Okay, he stopped trying to fight the police and start learning how to become invisible. Okay, so first the most important, to bypass the checkpoints, the hooks. Okay, so we use, so the EDA police have installed hidden CCTVs. Okay, so like the just call CCTVs the hooks. Okay, inside the most important office ntdll.dll. Okay, this is the office. Okay, ntdll.dll. So every time you want to talk to the government, the kernel, you have to pass through this office. The camera watch what you ask for. Okay, so the first trick is direct syscall. Okay, we use the direct syscall. Yep. So the villain knows the police area, police are watching the main highway. This is our main path. Okay, he pull out an old map. He finds a secret dirt road that bypass the highway entirely. Okay, we just say we choose a secret dirt part. Okay, so drive his car off road and go straight to the government banker Kernel, completely skipping the NTDLL office and its cameras. Okay, the police are watching the highway but nobody ever passed by. Okay, meanwhile the villain is already inside. Okay, so now we use another thing, the advanced version of direct syscalls. So okay, so we use the indirect syscalls. Okay, some new police or the advanced EDRs use drones to scan the whole site, like the dirt roads also. So if they use to see you driving off the road, they just shoot. Okay, so the malware drives up to the NTDLL office. Okay, and instead of entering the room with the camera, he jumped through the window. Okay, into the safe zone right behind the camera. The drone from far away, it's look like he is in the legitimate office, but he is actually skipping the check. Okay, and then the third method we will use the unhooking. So it's little bit it's the advanced part. The villain walk into the office and sees the CCTV camera, the hook. We call it the hook CCTV camera, and he pull a brand new clean copy of the office wall, a clean ntdll.dll form, and paste it over the camera. The police think their camera is working, but it's actually staring at a fake wall. Okay, the villain can now do whatever he wants. Okay, so is in process, but how we make this process? It's quite advanced. We make it maybe is another session. Okay, one by one, but now we see how the Win32 APIs are help. Okay, now the next is process of vocation. Okay, the villain need a place to hide. He cannot just stand in a street, right? like a run as malware.exe, or he will be spotted. He needs a space. Okay, so there is, we use some tricks, we use some techniques. The first one is process hollowing. Okay, so the malware sees an innocent trusted worker. Okay, like the host.exe or the cron.exe. Okay, so he start the cron.exe process but tells it to pause immediately. While it frozen, he scope up its brain and map its memory. Okay, and put his own malicious brain inside. Then he tells to restart, just like this. Okay, so the task manager says, "Whoa, it's Google Chrome is running." The antivirus says Chrome is safe, but inside it actually the malware controlling the body. Okay, we just hide the malware inside the chrome.exe, the trusted application. Okay, then the another technique, we call it ghosting. Okay, or we call it process doppelging. Okay, it's a doppel, whatever it's, but I'm calling it ghosting. Okay, so antivirus scanner check file on the hard disk. Okay, if you save a malicious file, they just got it. Okay, so the malware create a file and quickly loads it into a RAM and then immediately delete it, or like rolls it back before the antivirus can blink. So the process is running in memory, but if the EDS or antivirus look at the hard disks for evidence, the file does not exist. It is ghost. Okay, so it's like that. Now the problem. Okay, so there is a problem like anti-analysis. Okay, like like if I am a hacker, or if I inject malware in any system, so I think like am I being watched by a researcher or a sandbox researcher, like the malware researcher, the malware analyst. Okay, or any sandbox. Okay, so I need to test some process, like I need to add some test process in my malware. Okay, so for this we use some another tricks and we use some another functions, APIs. So first, the time check, the stopwatch test. Okay, so when a security researcher analyze malware, they go step by step, they do debugging. This takes time. Okay, so what is the trick? So the villain or the malware look at this watch. We use the get ticket count. Okay, we use this get ticket count. He runs a tiny task, then he looks at his watch again. Okay, did that take 1 millisecond? God, I am safe. Okay, but did that take 5 seconds? Whoa, alert, someone is pausing time to study me. Okay, so I'm just self-destroy immediately. Okay, now the second trick, how we know that the researcher like spy us, see us. So the second trick is the background check, the anti-virtualization. Okay, so the malware check the furniture in the room. Okay, like does the mouse driver say it's a VMware? Does the hard disk say it's a virtual box? If yes, I am in a simulation, a lab. Do nothing but be innocent. Okay, it's a silent malware. Okay, you understand that it's just a lab. Okay, so this this is the things we do whenever we make any malware. Okay, we need to remember all this step. Okay, so like our malware has sneak into the building. Okay, we just inject it and hidden his identity. doing obfuscation. Okay, but there is a still problem. The building, the operating system has security cameras, okay, and microphones everywhere, and the malware need to call his boss, the hacker, to send the stolen data. Okay, so how does it do without getting caught? Okay, so we need a C2 server. Okay, so Windows has two major security guard inside every room. One is AMSI. Okay, so anti-malware scan interface. This is the scanner. Every time a script like a PowerShell try to run AMSI, scan it and ask the antivirus, is this malicious? And another is ETW. Okay, so ETW, okay, we just see the screen. So this is the AMSI. You just scan all the things. Okay, and the another one is ETW. Okay, so it's a event tracing for Windows. Okay, this is the CCTV camera. It records everything. It's everything that happens, logs, and send it to the security team. So we cannot destroy the guards. Okay, we cannot destroy the guards. So instead we decide to manipulate them or the brainwash them. Okay, so we do the AMSI patching. Okay, the villain, the malware find the brain of the scanner. Okay, it's in AMSI.dll, the loaded in memory. Okay, so he used a spell called virtual protect. Okay, he used this called virtual protect to make the brain writable, so he can change thoughts. Okay, so he changed the first instruction in the brain. Instead of scanning, he forced it to say everything is fine, no virus here. So technically it's called he override the AMSI scan buffer function. Okay, so okay, yeah, so he just override the AMSI scan buffer function with using the MOV or some assembly language, the raw language, like the previous live video we talking about assembly language. Okay, so now you see guys, it's like it's very important. Okay, so this tells the system invalid argument. Okay, so which make AMSI fail and lets the malware run. Then the modern bypass. Okay, so in 20 okay, so in 2025 or the upcoming 2026, security cameras check if you touch the brain, like the memory scanning. Okay, so the solution is VEH2. Okay, so the villain does not touch the brain, he sets a hardware trap. Okay, so one second. Yeah, so he sets a hardware trap, the breakpoint. Okay, when the scanner try to work, the trap activate and the villain redirect the traffic around the scanner without ever changing the code. It is invisible and modification. Okay, so this things we just bypass this and this. Now the time calling the boss, like now we has the malware has the stolen the data. We need to call my boss, my like the hacker, the creator, the developer, the command and control server. He has two phones he can use. Okay, so option 1, WinSock. For C2 server we can use WinSock. So WinSock, like what is it? Okay, so this is the raw, like the manual phone, WS232 DLL. Okay, so you have to build the connection yourself. So you have to dial the number, connect the wire, and speak the raw data like socket. We use connect, send, and all. Okay, so you have the full control. You can speak in secret code. It's but yeah, we use this secret code, but there is a problem. It's look suspicious. Why? Because the normal employees, the normal apps don't use burned phones. If the security team sees the wire traffic, they caught you. Okay, so we use Winnet. So this is the official high level phone, the Winnet.dll. It is the same one Microsoft Edge use. Okay, so you just say open website and it handles the cookies, proxy setting, and HTTPS certificates for you. Okay, so your call looks exactly like an employee browsing the internet. The security team thinks you are just reading news, but you are actually sending the password to the boss, right? So yeah, so we just complete a malware circle, and we see we see that how the Windows 32 APIs are very important, and how for the basic malwares how we use it. Okay, so what so we just recap. Okay, so what have we learned today? We learn that your innocent computer is actually a high security government building run by a very strict chief minister, the Kernel. So we learn the malware is not some magical like things. It is just a very clean con artist. Okay, so it worked it through the front door using the receptionist. We call it the kernel 32. Hide inside the pocket and or a trusted employees. We use svc or host.exe or any file. Okay, then we brainwash the security guards, the AMSI, and then use the official phone we need. Okay, to call its boss or while pretending to watch a cat video on the internet. Okay, so basically we learned that Windows is extremely polite, just like your girlfriend. Okay, so you asked it nicely, and with the right API, with the right gift, it will happily help you rob the bank. Okay, so now you have to knowledge. Okay, you know how to lock words works, you know where the cameras are hidden, you know how to walk through the walls. But there is a final piece of advice: use the superpower to test defenses. So find bugs and make system safer. Be the white hat hacker, like who finds the hole in the wall and fix it. Okay, not that one who sneak into the steal the Wi-Fi password. And the one last thing is, it's a very important thing. If you ever try this on a real bank or a real system or a real website, or like your college server or your ex laptop, and the cyber police come knocking at your door, please, for the love of the God, don't say I am your mentor. Okay, I was never here, we never meet. This life was just a collective hallucination. Okay, so good luck, stay dangerous, and happy coding, and enjoy your Christmas time. Okay, see you in the next live video. If you guys have any question, just comment, and if you want to connect with me, just there is some link in description. You guys can connect with me through LinkedIn. Okay, so we just end our session. Bye bye guys. I think it's end.